Hi, this is Dr. Joel Duff from thenaturalhistorian.com. Yes, I know I've published a number of things on coronavirus recently, but I just had to talk about it one more time, and that's because I read an utterly fascinating paper. It's about the Russian flu of 1889 to 1991, or as we're going to see, really 91, 92, 93, and so forth. And the really intriguing question from that is, hey, was that really an influenza, or could it possibly have been coronavirus? But let me share my screen and we'll get started. All right, so the Russian flu of 1889 to 1891. Was it a coronavirus? And if it was a coronavirus, maybe we could learn something by looking at this past pandemic. So rather than looking at the 1918 flu, which was an influenza flu, and looking at the various waves as they come through over a year to 2 years, what can we learn from the Russian flu? All right, so the paper of interest is this one that was just published in the journal Microbial Biotechnology. And the authors here are looking at clinical evidence that the pandemic from 1889 to 1991, called the Russian flu, might have been an earlier coronavirus pandemic. And so in this paper, they provide their observations that lead them to conclude that this, in fact, was a coronavirus outbreak rather than an influenza outbreak. And I think that's fascinating, given some of the things that I've talked about before about the evolution of this particular viral family and what we think has happened in the past. And so I'm going to try to connect that with some of the things I've said before. So before we get into talking more about this Russian flu, let's look at the history of deadly plagues, epidemics, just to give you some perspective on what this flu was. So here's the Russian flu we're talking about right here in 1889. They say 90 here, but it clearly went into 91 and then was evident a few years after that as well. Estimated to have killed about 1 million people, but of course we have poor records keeping in most countries at that time, so it's very difficult to tell. A much smaller number, of course, than the Spanish flu, which has wildly divergent estimates of the number of deaths caused, but nonetheless a much larger number and considered the worst pandemic in history in terms of a viral outbreak. And then we've got our Ebola and MERS and swine flu and SARS coming in rapid succession in recent years. Of course, many of these were squelched very quickly and did not have very high death rates. But the current pandemic is COVID-19, and at the time this particular figure was made, it was 500,000 deaths, but now it's about a little bit over 2.5, around the 2.5 million. So the Russian flu back here is not one that we normally talk about, but I think that I will convince you that it is actually quite interesting and maybe relevant to things we're dealing with today. So let's take a look at the abstract and get a flavor for what's in this paper. They look at contemporary medical records from Britain and Germany on patients suffering from a pandemic between 1889 and 1891. Right, this was called the Russian flu, and it shares a number of characteristics with COVID-19. Now, I want to tell you before I dig into this any farther, I've read a lot of the coronavirus literature, especially on papers about the evolution of coronaviruses and the viral family. And in that, they talk about the other different human coronaviruses. And there's been speculation in that literature for the last 10 years that potentially this Russian flu was a coronavirus outbreak. And I'll tell you why they thought that before when I talk about those coronaviruses. Most notably, so what are the things that sort of tip them off that this is really a coronavirus-like thing instead of influenza? Multi-system affections comprising of respiratory, gastrointestinal, neurological symptoms, including loss of taste and smell perception. Does that sound familiar? That's very unusual, if not extremely rare for an influenza virus. Also, protracted recovery times resembling long COVID, and observations of thrombosis in multiple organs, inflammation and rheumatic afflictions. And so, in other words, blood clots in multiple different organs. Later in the paper, they also talk about people's inability to breathe. All right, that their lung capacity is, and that's probably from blood clots, which again, an unusual feature of an influenza. So, unlike influenza, there's a lot of COVID-like features here that very much sound like descriptions of modern-day patients. They also found that mortality was seen in elderly subjects, while children were only weakly affected. Right? That's very different than most of the other influenza outbreaks, which often affected very, very young, sometimes not so much in the teens, and then after that, sort of a typical profile of more and more toward older age. But nonetheless, very different than the current, I don't know how to describe it, the current distribution of cases, at least severely affected cases. Also, there were contemporary reports of trans-species infection between pet animals, horses, and humans. All right, and we're also seeing that. Another paper I'd love to talk about, I don't know if I'm going to have time, is this recent thing about how so many deer in the Northeast U.S. have been shown to have had COVID-19, right? They had the antibodies for it. And in fact, it's a large portion of the population. So it appears that coronavirus has jumped from humans into somebody somewhere had enough contact with a white-tailed deer, and then that deer has probably spread it to a whole bunch of other deer. Now, we don't know a lot about that particular coronavirus because it hasn't been sequenced yet, and we don't know how different it is. But nonetheless, we also know that it affects mink, right? That it's definitely gone from humans to mink, gone from humans to dogs and cats, right? It's gone from humans to various animals and zoos. And this also would not be typical of an influenza. Yes, you might be thinking, well, what about the Hong Kong flu and these things, ducks sometimes, or the swine flu? Yes, there is crossover, but not nearly as widely as like your cats and dogs and things like that, all right, showing similar symptoms. Right, so then this last part says this concurs with a cross-infection by a broad host range bovine coronavirus, and as we'll see in a moment too, that this particular coronavirus they're suggesting came from cows rather than bats or civets in our case, and dated by the molecular clock argument back to about 1890. This is where I was saying earlier, in the last 10 years, others have suggested that there was a coronavirus that entered into the human population, all right, from an animal source around the late 1880s, all right, and this is 1889. And the way that's calculated is, all right, as viruses move through a population over time, they mutate. We're seeing that, right? All the different variants. And as they since they mutate over time at some regular pace, if you look at how different the coronavirus strain is today in a human lineage and compare it to animal lineages, and you just add up the number of differences between the two, you can back calculate when they had a common ancestor. In other words, when was the moment in which that virus was in an animal and crossed over into human beings? And that's the estimate for one strain of coronavirus that was pegged toward the late 1800s. And so that is an interesting coincidence that our molecular clock methods suggest a coronavirus invasion into humans around the same time there is this Russian flu. And the bovine thing has to do with in the 1880s, there was a lot of bovine viral infection going on, and there was basically a pandemic among bovines, all right, cows, especially in Russia and Eastern Bloc areas. That's one of the reasons why this is the Russian flu, is it comes from that particular region, thought to be sort of from that particular region. And so the suggestion now today is that it was something that was in cows, and because they had it so prevalently and they were around people, that it jumped from cows to humans. Now, this probably wouldn't happen with influenza because cows really aren't going to harbor influenza. It was very doubtful that those infections in cows that were causing a pandemic in cows was an influenza, but not unlikely that it was a coronavirus, because we know coronavirus infects hooved animals. I mean, I just told you about the deer, right? And it's spreading like wildfire among the deer, and deer aren't that different from cows. And so here we have another coincidence that you have this horrible outbreak of viral infection that's affecting cows pretty much all over the world, but especially in Europe. And then all of a sudden, very soon after that, or during the very latter stages of that pandemic, then you have human beings coming down with this pandemic that ends up killing 1 million people. Okay, so let me see what else we can say here. Oh yeah, let's back up. And I've been saying a lot of things about coronavirus, and I just want to remind you, because this is a broader story of coronavirus. It's not just about COVID-19 or SARS-CoV-2. I want to remind you that there are other coronaviruses that are inhabit or have been circulating among human beings for quite a while. So we have in this chart right here, what I'm showing is each one of these colored groups are different major groups of coronavirus in what's called the coronavirus family. And you can think of the family as a whole bunch of related species or types of viruses that are all coronaviruses. And so you might hear about like an alpha group coronavirus, or the beta group of coronaviruses. And then there's beta coronavirus A group, and there's a D group and a B group and a C group. And by the way, alpha and beta and the gamma and the delta here are beta. That's not the same as you're hearing like the Delta variant. Those are Greek letters for variants specifically of SARS-CoV-2. The family's already had these name designations. There's a little bit of confusion there. All right, so there's these different groupings, and what the groupings suggest is that they are all similar to each other. So anything in the same group are very similar viruses to one another, but they still might affect many different kinds of animals. But nonetheless, they appear to have a common origin. So if you go back in time, there was maybe one particular version of that virus, and then it invaded a variety of different organisms, and since then has sort of speciated out, right? It's had mutations and become separate lineages of viruses now that inhabit and live within these particular organisms. So these red things right here, this one right here, this lineage right here, HCOV stands for human coronavirus, HKU. This is human coronavirus OC43, and that's the one we're going to be talking about. That's the one that's really interesting to us. And then, of course, we've got SARS-CoV-2, all right, which lies in the beta coronavirus lineage B, and also SARS-CoV, the original coronavirus, SARS, severe acute respiratory syndrome. Those two lineages are similar to each other. You see how the SARS-CoV and SARS-CoV-2 are both found in the beta coronavirus lineage, which is also inhabited by a number of other very similar bat viral lineages. And then you may have also heard of MERS, Middle Eastern Respiratory Syndrome. That's also a coronavirus, which is far more deadly than SARS-CoV-2. And it's in the C lineage, meaning it's genetically distinct from the SARS-CoVs that we are dealing with now. And then over here in the alpha group, there's also HCOV229E, HCOV-NL63. This causes a cold. All right, you may have had this. You may have had one of these. All right, many of you, actually, maybe most of you listening have had HCOV229E or HCOV-N63 or HCOV-HQ1, which actually is a fairly rare version of the virus and causes a little bit more severe symptoms. And it's more, I think, gastrointestinal than it is respiratory. But the one we're interested, again, as I said, is HCOV-OC48, which is actually a very common virus in our environment, meaning the environment being us. And it causes typical upper respiratory symptoms like a cold. And so again, many of you might have had HCOV-OC43. This is the virus that is thought to, if you trace back, oh, now I already erased it, but here it says antelope. And one of these over here is a bovine, actually B-CoV right here. That's bovine coronavirus. And you see the lines going to these are not very long. Well, a not very long line represents not much change has happened, right? Not many mutations have accumulated since they shared a common ancestor. Common ancestor would be right here. Actually, I think this is a bovine coronavirus as well. And so this particular human lineage of coronavirus is very similar to a bunch of hooved animal coronaviruses. And so again, that makes sense that maybe this Russian flu actually came from cows crossing over and getting into humans. So that's what this is, or this chart over here is showing the various lines of coronavirus that are in human beings, including, our SARS-CoV-2. What's not on here is SARS-CoV-2. Sorry, SARS-CoV. CoV-2 is not in here because this is an old figure. See, 2018, that's before, before 2020. So they didn't have it on here. But here's HKU1, OC43, 229E, and L63. All of these are considered indigenous or viruses that are circulating in the human population. And these are their probable sources. Most, maybe from bats, then maybe through camels, and then into us. In this case, OC43, we're pretty sure it came from a cow to humans, or some kind of cow-like hooved animal, but may have originally come from a mouse lineage, because the older lines back here are more like rodents down here. And so the rodent lineage then seems to have gotten in. See, this is R rodent. The rodent lineages eventually got into hooved animals, which eventually got into us, right? That's the amazing thing about this family, is that if you trace all these lines back right here, and you'll see that all the coronaviruses appear to all be related by a common ancestor. So we'd say, like right here would be the common ancestor of all these different coronavirus lineages. And this origin point is not thought to be very, very old, possibly on the order of only a couple tens of thousands of years. This would be considered an extremely young viral lineage, and which means this viral lineage is just it's still expanding. And it's still expanding into the biosphere, and it's still finding ways to get into new species of organisms on Earth, right? And there's tens of thousands of vertebrate animals, not all of which have coronaviruses already. And so they're finding their way into and through, and in fact, they have found their way into many animals and then into us, creating many different lineages of coronavirus in us. And this is probably true for other animals as well. Some of them probably also have 4 or 5 different coronaviruses that could infect them. So as a young family, it's intriguing because, and it's a little scary too, because it suggests they're not done, right? They haven't, this virus family being so young, it's still exploring that space of organisms to infect. It's still figuring out best ways to infect them, maybe the best ways to get along with them, all right? Because ultimately, if they kill their hosts, they will go extinct. And so finding ways in order to, they're certainly not going to be mutualistic. They're almost always damaging to some extent. But if they can find a way to not do so much damage to their host, then they will be passed on, all right? That's why the cold is so great. I mean, that's why OC43 still exists, right? Because if you got OC43 and you had a cold, you'd walk around and you'd cough on people, and other people wouldn't be totally offended by that, and they wouldn't run away, and they wouldn't wear a mask, and so it spreads itself around, all right? And it does so because it doesn't do enormous damage to its host, but it allows itself to continue to propagate, and that's true for all these lineages up here. Now, here's the critical thing, right? I hope you're thinking about this. What happened to the Russian flu if it was coronavirus? And I'm telling you that HCO43 is what people are saying was responsible for it. Well, how did OC43 kill 1 million people and create waves of pandemic across the whole world for at least 3 years, from 1889 up to about through the end of 91? And then there's even evidence of some minor waves after that. So let's call it a 3 to 5 year window in which the world was concerned about this pandemic in the world. And yet that virus still is alive today. it's still propagating in humans today, and yet we're not concerned about it. Do we just get used to it? We're just like, okay, it's there and we don't care anymore? No, if it were doing the type of damage, the things you read about in this journal, about the symptoms and, the people in hospitals and so many cases, waves going through villages and virtually everybody getting sick, right? We would notice that, right? We notice coronavirus in our environment today. And we're trying to do something about it. So what happened? What happened to OC43 if in fact that is the viral strain that came from cows? Well, when it first got to humans were not ready for that particular strain. This is a beta coronavirus, so it has a similar genome structure to our SARS viruses. So maybe that's why they have similar symptoms, as opposed to the ones down here in the alpha one, which don't seem to have caused those types of symptoms. Right. So so I've talked about this. If you wanted to read about the family history, and I gave you just a brief version of that. If you want to read about the family history of coronaviruses and its origins and then possible future prospects, this article I wrote way back at the beginning of this latest pandemic in April 2020, still reads, I feel pretty good about it today. I think it still is very accurate within the sense of describing the family of viruses and the variation of those viruses and what that means for the history of the virus over time. I think what everybody wants to know is, what's the future going to be like? What's going to happen to coronavirus, right? COVID-19. And so we always try to look into the past and see if there are any hints, right, or future projections. So far, COVID-19 has been tracking with the large epidemics of the past. We're seeing large waves go through the world. Right now, we're on wave 4 or 3, depending on how you want to count them. And of course, that's sort of a global average of coronavirus and what it's doing. If you look at each individual country, some are just really like Indonesia, Taiwan, Vietnam. They're really just hitting their first wave in a way, first significant wave. China, you could say, had one wave and then nothing after that. And now they're actually experiencing the Delta variant and is creating a problem in China. And so that's part of what's going to happen is that over time, what will happen is there's going to be hot spots in some parts of the world where they're going to experience additional waves of virus. But the global pattern from all past pandemics shows that the waves will dampen over time. All right. And then what does it mean to disappear? It's not really going to disappear. Nobody expects this virus anymore to just disappear from the human lineage. It's going to be something like OC43 or some of those other coronaviruses I just mentioned. How mild will the symptoms be? Not sure. Will it be like the flu? I think it's going to be much more likely to be like a bad flu all the time. More so than just a common cold, but maybe it'll reach a point where it's like the common cold. Wonder how does that happen? Like, okay, first of all, let's go back to 1889, 1891. What happened there? Because if that was a coronavirus invasion from a host and it had similar symptoms to COVID-19, remarkably similar symptoms to COVID-19, so seemingly about as virulent of a virus, seems to have been easily spread, probably again through aerosol. So it's very similar to what we're experiencing. So I think looking back to see what happened there might be informative for what the future holds here. There is one big caveat, though, one big difference between those times. There's lots of differences. One big difference. We have a vaccine, and they didn't have a vaccine. And so it's interesting to think about how the vaccine might interrupt this trajectory that I'm going to tell you about in a moment. That trajectory is this. The trajectory of the 1889, 1891 Russian flu is very similar to this 1918 one. There were multiple waves that crossed over, or waves that went through the world, right, reaching at different places at different times. And then that lasted for almost a full 3 years. That's kind of the bad news here, right? Because we're only like not even 2 years into this thing. So that coronavirus lasted a good solid 3 years of interruption in the world. But it wasn't just 3 years. There was really another year and a half, maybe 2 years, in which there was noticeable amounts of virus causing noticeable problems. Those problems you can think of as like being individual problems in individual places, not like the whole. If you took the whole world's data and piled it up, you would only see smaller blips, right? But that's because the virus wouldn't be common in a lot of places, but it might be very common in some local situations. And so that is probably what is also what we're going to be looking at after this last Delta wave is we're going to see a dampening down of the virus in most places, but you're going to see it popping up in a few different locations. Now, the caveat here, of course, is Lambda, the next variant. Will that kick off another series of waves, especially if it can get around the vaccinations? All right. But you're probably wondering, like, well, but then what, back here in the late 1800s, what caused it to damp off? I mean, why did eventually there weren't as many cases, and there weren't, most importantly, why wasn't there as many deaths? There actually might have been still a lot of cases, but those cases might have been mild enough that nobody would report them or talk about them, right? They wouldn't have made a big dent in anyone's logbook. So what's happening there? What's happening there is a combination of a couple of things. One is when a virus first comes into a population from a new source, not just like, hey, this is next year's flu, which had a few tweaks to it, right? You had mutation here, mutation there, and now my body's not quite used to it, and so it still might react to it. No, this is like a brand new virus, all right? So this coronavirus, brand new to the human population. By the way, all those other viral coronaviruses I showed you earlier, they're thought to all have come later in human populations. Maybe once earlier. Yeah, I might have forgotten that. But anyway, I know that all of them, but possibly one, are much younger, right? So they're sweeping into the human race in recent times. So this coronavirus came in, and we had really no experience with coronavirus, our bodies, our immune systems. And so, we would, fire off a response to that. And then what happens is the virus fights back, right? It reacts in a way because it's still trying to figure out us, right? That virus enters in a line. There are lots of people spreading it around. And as they spread it around, they make mutations, and the mutations that cause the virus to propagate faster in us, which potentially causes more damage to us. They end up sort of dominating, right? They become more common. And then they create yet another wave of virus that propagates through the population and affects a lot more people. And then you might have more variants and so forth, and more change, and yet another wave and so forth, right? But as the virus begins to sort of figure out this new situation, right? As there's sort of give and take between human beings also adapting, because as more people get infected, they now develop antibodies, and they have some resistance to it. So as it comes back to them, the virus now no longer what it did before isn't going to work very well. But rather than become more virulent, all right, more deadly, one strategy for the virus, all right, one thing that natural selection can do is it can select in an environment where lots of people are somewhat immune to something, and you can get immune either by having had it or through vaccination, is what natural selection does is it looks at the virus, and if the virus can find better ways to spread, it needs to spread, and in order to continue its existence. And if more people are resistant to it, it's harder for the virus to find more victims, right? So the best way to find more victims is to become more easily transmissible. Well, what's one of the best ways to become easily transmissible for this type of virus? To congregate in your nose, all right? If you can find mutations that allow you to specialize in the nasal passageways. But if you specialize in the nasal passageway, you might lose your ability to propagate well in other parts of the body, which require different conditions to get into the cell, propagate in the cell, trick the immune system, and so forth. So as you adapt to the nose, right, you then become, I mean, a bad infection in your nose is probably not going to kill you, right? And so as these viruses become more adapted to transmitting and finding ways to transmit themselves to the next generation, they then lower their virulence. Not that they're trying to lower their virulence, that's just what happens. It's a trade-off. And so they need to transmit lots and lots of virus in order to find the few individuals that might be highly susceptible to that virus. And then that person gets the virus and it goes into the nose and it stays in the upper respiratory tract and propagates itself there and escapes to the next host again. Right? So that I hope you can see that is a way in which basically the virus evolves with human beings. In order to continue its survival, it needs to become milder and milder and milder. Right? It needs to become more transmissible, and to become more transmissible, it's harder to also be deadly. And that would be one of the reasons and one of the expectations on most viruses. Now, this doesn't mean this has to happen in some orderly fashion. It's not impossible that for a short temporary period, there could be a new variant that is highly virulent, right? But also spreads fairly well. And that variant could cause a brand new wave that's worse than any one we've already had. But eventually, all evolutionary theory, I'm not going to say all evolutionary theory, but almost all evolutionary models and natural selection models and understanding of the different stresses that these viruses are under and how they would react suggest that in the long run, the way it should play out is respiratory viruses should eventually evolve from viruses like this. And this is what we've seen happen over and over and over again. It's likely that all those other coronaviruses that are now common colds, when they first came in the human population, they may have caused something that was more dramatic. And maybe we just don't know about in history, or maybe we're misidentifying other flus as coronavirus from the past. So the good news here is that probably that's where we're headed. The bad news is it doesn't necessarily mean it's going to happen tomorrow. There could be highly virulent strains of coronavirus or SARS-CoV-2 that might still stick around for a year or two before we get to a point where milder strains then begin to propagate faster. Because all it takes is one very transmissible virus, right? Highly transmissible virus that resides mostly in the nasal cavity and doesn't really get into the bloodstream, and therefore doesn't cause the blood clots and all the other problems. Once that particular variant occurs and begins to spread, and if it spreads faster than all the others, in other words, if it outcompetes the other variants, then it will then circle the globe in one giant wave, except that wave won't be very deadly. And then all of a sudden, boom, it'll all crash, right? It'll all crash down. The deaths will all crash down. The number of cases may actually continue to be relatively high, but we'll see the deaths dramatically drop off, and we'll also see the symptoms drop off into more mild symptoms over time. I think that's the most likely outcome. I can't really predict the timing of that particular event. But I think maybe it's comforting to see that, there was a coronavirus in the past. It caused millions of deaths, potentially millions of deaths. But now you and I get that virus, and we're not concerned about it at all. So that day, I think, will come. I just don't think it's going to be in the next 6 months, or probably not even in the next year. All right, I think I'm going to quit there, but I hope you found that. I hope you find that helpful and interesting. I just found it fascinating that we're still learning about the past, right? And one thing that hasn't been done yet, like the 1918 flu, is for the 1918 flu, they were able to find victims of the 1918 flu from Alaska that had been buried in the ground and essentially in permafrost. And they were able to dig up those people, or remains of those individuals, and they were actually able to isolate the virus from them. And so we have confirmation of the genetic, the actual genotype of it. So we know like what H1, H15, whatever, I can't remember what variant of the influenza virus it is. But we know the sequence and the code of that virus, and we can compare it to today's, and we can see how it's changed over time. because flu variants also do the same thing. They don't really go extinct. They just mutate, and they mutate themselves into milder strains of the flu. And so I suspect now that this is, now that we have this coronavirus and we really want to know what happened in 1889, I think somebody's out there probably looking for, some victims and hoping to be able to extract and actually show that they have the COVID viral particle in them. Probably also looking at some of those cows as well, if they have any remains of those. And so that would be like the final confirmation. But I found this evidence to be compelling enough to consider it to be the leading cause, right? The leading theory for the cause of the 1889 pandemic. All right, I'll stop there. Again, my name's Joel Duff, and you can find my writings on thenaturalhistorian.com and my videos here on YouTube. Please subscribe if you thought this was at all interesting. We'll talk to you later. Bye-bye.